Hi, everybody. My name is Frederick, and today I'm going to be talking about how to read scientific papers. Um, Reading scientific papers is a very important skill in really any scientific field, but especially in astrophysics. So today, what I'm going to do is I'm going to show you a couple of tools that I use to uh, read and categorize scientific papers, and then I'm going to kind of go through a paper and show you how I would go about reading it. So the first tool that I use here is the astrophysics data system. It's just essentially a large database of astrophysics papers, and there is a really robust search tool here, as you can see, that you can enter in commands for all sorts of different requests. It's a little daunting at first, but once you get the hang of it, it can actually be quite quick. There are also a couple of other different ways of searching for papers. Here's the classic form, and here's it's called the paper form, but I like the modern form just because it's pretty quick. So let's find a paper, I guess, on exoplanets, just so you can see how it works, and let's get it from the archive because I want it to be publicly available. And let's, I guess, take a look at this one. So as you can see, you get the abstract, and then a little bit of information about the paper. You get a link to in this case, it's on the archive, which is always nice to see. And I find a very important tool here is the export citation tool. This gives you just a pre-made bibtex citation, which you can copy and paste straight into your .bib file in your LaTeX document, and it will make a very beautiful citation for you. You don't have to do any work. This is great. There are also a bunch of other formats. I don't know what any of these formats are, except bibtex, because bibtex is so great. Another tool is the Mendeley library tool, which is essentially just a way of categorizing all the papers that you read and putting them into a library so that you can access them from anywhere. There is also an app you can download, which will allow you to access them locally from your computer so that you don't have to be connected to the internet. The way this works is fairly simple. You can just type in your search term, say exoplanets, and you'll get a bunch of papers on exoplanets. So we can look for ones that are open access, for example. And if you look at this, well, this is already in the library, but we can, I don't know, let's add this to a library, and then we can look at our library. And it looks a little like this. And so you can read the paper, you can get the PDF and download that. You can make a little notebook here, so adding some notes. Say this paper is genius. And you can add annotations about a given paper. Also, when you open it up, you'll see there are all sorts of little additional tools here. You have a little stylus tool, highlighter. You have a commenting tool, and you still have access to your notebook. So this is all very useful. I mostly use Mendeley just to kind of create a library more so than take notes. I prefer to take notes, pencil and paper, but to each their own. So let's, I guess, take a look at this paper, and which I haven't read, so maybe it's crap, but we can take a look at this paper and I will show you how I would go about reading it. So the first thing to note is that with any paper, is this? Yeah. with any paper, how you go about reading it is going to be a little different depending on, first of all, like how you like to read papers is going to be kind of a personal thing. How you understand things, how, how, however works best for you is really how you should do it. So take everything I say with a grain of salt, and experiment. I think the best way to learn how to read papers is just to read a lot of papers and to find a bunch of different ways of doing it and kind of amalgamate all the ways that work for you and get rid of all the ways that don't. Another thing to note is that it depends on what exactly you're trying to do. So if you need help solving a problem, how you approach it is going to be a little different from if you just want background for a project that you're doing. Or if you're trying to, learn more about the state of the art in a new subfield, it's going to look a little, how you try to tackle the paper is going to be a little different. So I'm going to try and give you just sort of a general overview of how I do it, but keep in mind that this isn't, the only way. So the first thing I do is I always look at the abstract, because it gives you a good idea, really, of whether the paper has what you need. So you can read the abstract and say, oh, this doesn't answer, this paper won't answer my question. And then you don't have to read the rest of the paper, which is very useful. But I also don't spend a bunch of time trying to understand the abstract really deeply. It's really not meant to, be really illuminating on the subject, but rather more give you just a quick rundown of what the paper is going to be about. So if you read the abstract and you say, this is the right, I'm in the right place, like this is the paper I need to read, then great. There's no reason to spend any more time on the abstract. Then what I do is I tend to read papers in the order of introduction, figures, conclusion. So I always start with the introduction, which generally gives a little bit of background on the topic, which is often very useful for reading the rest of the paper. I find that if I'm really confused in the introduction, that's usually a sign that I need to go back and do more research on the topic, because a lot of times it's kind of laying down the information that they expect you to know. So you should have a pretty good idea of what's going on in the introduction. In general, the way I go about reading it is just paragraph by paragraph. So I go one paragraph at a time. I'll read the first paragraph. I will write down questions I have about it. I will try to articulate what it's saying. I often like to just say it out loud. And then I'll try to kind of summarize it in a sentence or two. And then see if I can, if I understand it well enough to move on to the next paragraph. So if I can write it down, that's usually a good indication that I'm ready to move on. Once I've gone through the introduction, what I do is I just completely ignore any of the middle sections of the paper and I go straight to the figures. Because in general, the figures should tell a relatively complete story about what's going on in the paper. And so I do the same thing for every figure that I do for each paragraph, which is I try and summarize what's going on in a paragraph or two. I try to explain the figure to myself, or if I have a friend nearby, I'll try and explain it to them. And then once I understand one figure, then I know I'm ready to move on to the next one. Once I've gotten all the figures through, then what I do is I read the conclusion. And it's usually in the conclusion that I get a good idea of whether or not I need to read sort of the meat of the paper. So where's the conclusion here? Right. So with the conclusion, I find it especially important, more so than in the rest of the paper, although this is always important, is to write down questions. Because usually, you'll read through the conclusion, you'll say, okay, that made a bunch of sense, or you'll say, okay, I have these questions and that means probably the answers are hidden somewhere in the rest of the paper. They're not in the figures and they weren't in the introduction. So that gives you a good idea of whether or not you need to read the rest. And also it gives you a good idea of what you should look for. Often you can say, oh, you'll just find a section that looks like it'll have the answer to your question. So that's very useful because it will sort of target your reading for the main meat of the paper, because there's often a lot of material in here. I find with especially theoretical papers, it's much more important to read the meat of the paper than for more, observationally based ones where you can usually get away with just looking at the figures, because you kind of need to read through all the math and understand it. I find it very helpful to work if you have a tablet to kind of highlight things as you go, and write little, notes to yourself about, and write little notes directly on the paper to, summarize paragraphs and questions that you have. And I would say that's about it. Once you finish reading the paper, if you kind of have a page of notes that gives you a good idea of that, kind of you think gives you a clear summary of what the paper is talking about, then and you can articulate that back to yourself in a way that you think makes sense, then you usually have a pretty decent understanding of the paper, and that's really the goal with when you're reading these. And it's not always so simple as it seems. It can be very difficult to understand a lot of these papers. So in addition to what I've talked about, there are a few resources listed on the class GitHub. There are these two links down here, which should give you more information about how to read a scientific paper. And then there are links to the ADS and to Mendeley. And I think the homework is just to read the scientific paper of the week. They suggest a way of taking notes, and I think this is a great opportunity to kind of, try that out and see if it works for you, and if it, and like, if it does, great. If it doesn't, great. I think most likely there will be some parts of it that work for you and some parts that don't, and you should, keep what works and throw out what doesn't and try to, replace it and change it. And remember that there really isn't a wrong way of doing it, so long as you kind of get to the end having a good understanding of what the paper is really about.